Everyone, for this particular lesson, we are going to discuss and focus on slope fields. Now, slope fields are actually mostly applicable if your differential equation is not separable. Later, we will discuss on non-separable differential equations. And the main strategy here is sketching the slope at any given point. Now, if you forgot about the concept of slope, just a quick recap on this, although you have to review it yourself. If your slope is positive, then it inclines to the right. If your slope is negative, it inclines to the left. If it's zero, it's horizontal. Now, the inclination depends on the value. So, for example, if your slope is 1, it's perfectly 45 degrees. Uh, if your slope is greater than 1, then it would be a little steeper. If it's lesser than 1, then it will be less steeper as well. All right. So let's try to apply it now. Suppose we have this function dy over dx is equal to x minus y. Now remember, dy over dx is simply y prime. So we can just rewrite it as y prime equal to x minus y. Remember, when we take the derivative of any function, that derivative is the function for the slope. In other words, this gives you the function for the slope. And that is what we can use in order to draw the slope field. So for you to easily draw the slope field, we have to create this particular graph or table, wherein this table shows us values of your y and values of your x, and we're going to determine the value of your y prime or your slope at any given value of x and y. All right, so let's try to find some values first here. So let's start with this one. So here, if you try to plug in your x and y to this function, for example, you will actually get a y prime equal to 0. What does it mean? It means that at negative 3 comma negative 3, so this is your negative 3, slope there is equal to 0. That means we can just create a horizontal line at that particular point. All right. Now, if we continue here, okay, and solve for it, we can actually see some sort of a pattern. All right. So if we try to look at it, if we try to complete this table, we can see a pattern by which it will help us easily find the value of the slope. So horizontally, this decreases. All right. Okay. And so we could already see a pattern that diagonally, this will be all 0. Okay. And that would enable us to sketch the slope field easily. Okay. So this would be all 0. Therefore, at these points, slope is 0. So we have, for example, negative 2, negative 2. This will be 0. Negative 1 will be 0. And since we have already created this, you don't have to look at the table already because we could already find out that this one will all be equal to 0. Now, similarly, here we could find out that at negative 2, negative 3, slope is positive 1. Where is it? Negative 2, then negative 3. This one, slope is equal to positive 1. So we can make somewhat approximate 45 degrees. Again, we can see a pattern that here, diagonally, this will be all equal to 1. Okay, so the next one with a slope of 1 would be at negative 1, negative 2. Negative 1, negative 2 will be here. Okay, so we can just simply approximate it. And so we can say that at this point, it is all positive 1. Okay, now on the opposite side, we can also find that these are all negative 1s. Starting from, you have negative 3 comma negative 2. So negative 3 comma negative 2 would be here. So it would be negative 1, negative slope. All right, the next one with a negative slope is at negative 1, negative 2. sorry, it's negative 2, negative 1 rather, which is this one. And so you could already somehow find a pattern here. Okay. Now, if we try to look at this one further, all right. So to the right of this one, to the right of this, we'll have a slope of, so if we try to look at it, a slope of 2. So it seems like going to the right. So for example, we have negative 1, comma, negative 3. Negative 1, comma, negative 3. Just next to this one, the slope is becoming becoming positive 2. So that means it's becoming steeper. Whereas to the left of this, the slope becomes negative 2. So it becomes more negative. So it becomes steeper compared to this as well. From there alone, we could already find a pattern on how to sketch the slope field. So starting from, say for example, the first one with a positive 2 slope, which is negative 1, negative 3. Negative 1, negative 3 is this, right? So we can just draw a little steeper slope, and we could already continue that particular pattern and just estimate it, okay? And so we can just simply estimate it more, meaning to the right, it should become steeper and steeper. Okay. But take note that these are all estimates only. They may not be exactly how it looks like. Like if you really try to find a slope, we are looking only here for a pattern. Now towards the left, we know that this becomes more negative. So the inclination would also change. Okay. All right. And it becomes steeper and steeper as well as we go further to the left. But then it's still negative. Remember that it's still negative. Okay. Okay. And so on and so forth. So we predict that the slope field more or less would look like this. All right. So for now, we are just going to sketch the slope field. The analysis would come next meeting. Let's have more example. Another example would be this. We have dy over dx is equal to x minus 2. Again, if we are to rewrite this, this becomes y prime equal to x minus 2, or simply y prime is the function for the slope. All right. So for us to be able to sketch the slope field, we are going to have this one. However, since we don't have a y here, therefore we say that we don't have any values, specific values for the y, meaning the slope is not dependent on the y, it's more dependent on the x values. And if you are going to solve this one, we are going to see that these are the values of your slopes. All right. Now, just to make it a little balanced, because if you try to look at it, the values of the slope ranges from negative 5 to 1. So it's more negative. So just to make it balanced, we can add more x values. And maybe we can focus on this particular x value so that you will have more or less a balanced value of slopes. Now, how do you analyze or interpret this? So this means that at any point where x is, say, 2, your slope is 0. any point, I repeat, where x is 2, your slope is 0. That means if my point is 2 comma negative 2, 2 comma negative 1, 2 comma 0, 2 comma 1, 2 comma 2, slope here is equal to 0. Alright? Because at any given point where x is 2, slope will always be equal to 0. And in the graph, where can you find it? It's actually this vertical line. So this vertical line shows you all the points where x is 2, regardless of the y. So at this vertical line, we can assume your slope would be 0. So now we are ready to draw your slope field. Alright? So starting with this one. This will be 0, 0, and so on. So see, we can actually see a pattern already. We don't have to complete the table because by just putting some values in the table, we could already somehow find a pattern. Now, if we continue at x equal to 3, your slope is positive 1. So we can predict that it will be inclining to the right. On the other side, at x equal to 1, your slope is negative 1. So we can just predict to be like this. So if you want, you can use a ruler just to come up with a perfectly 45-degree line. So here we predict that as we go to the right, it becomes steeper. We go to the left, it becomes steeper as well. But the inclination would be inclining to the right as we go to the right and inclining to the left as we go to the left. So we just simply adjust. So make a little bit steeper as we go to the right. So again, this is just some sort of an estimation until we already see the pattern of our slope fields. So what we're after here actually is the pattern of the slope field because the pattern gives us the solution. So again, these are non-separable, meaning the strategy we had last time is not applicable. So we cannot solve it the way we did last time. Therefore, that's why we need to come up with this particular slope field in order to find its solution. So right now, you might be able to see already the shape, no? So let's just continue to the left. So it looks like that this is parabolic. Hence, we can say that the solution of this would somehow be containing a square. Okay? Remember that we have an x. Integrating the x gives us x squared. So this shape really tells us somehow the solution of this differential equation. And that's why this is being used, especially for non-separable differential equations. Okay, and this is how the slope field would look like. Again, the analysis would come next meeting, but for now, I just would like you to draw the slope fields.